Welcome back to the channel of ChemPacific. In this video, I'm going to discuss with you about two important questions from the topic liquid ammonia. Now, liquid ammonia is a very important topic for any kind of exams, NET, SET or GET. So, whatever I'm going to do over here is not only I'm going to explain you only the answers of only these two questions, but I'll be explaining you in a very detailed form so that in future अगर इस टॉपिक के ऊपर आपको कुछ भी क्वेश्चंस आए आप वो भी सॉल्व कर सकते हो, उसके लिए भी आप प्रिपेयर्ड हो जाओ. So before we get started, if you're new to our channel, don't forget to subscribe our channel, and if you like our video to press the like button. Now let's get started. Now liquid ammonia के ऊपर मैंने पहले दो क्वेश्चंस लिए थे, एक है जून 2019, ये भी पार्ट सी का ही है, and another is December 2016. Now first let me explain the question of June 2019 and then I'll move on to the next one. Now see, liquid ammonia is a solvent. So when you talk about solvent, the first thing which comes to your mind is water. Okay, so water is also a very good solvent, and exactly like water, liquid ammonia is also a very good solvent. Now since water, like, it gets dissociated, water being a solvent, we know that it gets dissociated into H plus and OH minus. ठीक है? Likewise, so H plus, how do you write H plus? You basically write H plus as H3O plus form because H plus does not exist. So H3O plus and OH minus. Likewise, the liquid ammonia being a solvent, it will also get dissociated into NH4 plus and NH2 minus. Clear? So in this case, जैसे ही water dissociate होते हैं to its corresponding cationic part and anionic part, वैसे ही liquid ammonia dissociate to its corresponding cationic part and anionic part. Now liquid ammonia is a very good solvent for all alkali metals, because whenever the alkali metals they get dissolved in liquid ammonia, it results in the formation of ammoniated electrons. ठीक है? And because of this presence of ammoniated electrons, the solutions of metals in the solution of alkali metals in liquid ammonia, they act as very good reducing agents. So I have given you the reaction whenever any alkali metals get dissociated, gets dissolved in liquid ammonia, it results in the formation of ammoniated electron. ठीक है? So this is your ammoniated electron. And due to the presence of this ammoniated electron, the solution of alkali metals in liquid ammonia, they act as a very good reducing agent. So that is why I have given you a lot of examples over here, and that is why कोई भी FeCO5 when it is reacting in a solution of alkali with liquid ammonia, FeCO5 will get reduced to FeCO4 2 minus. So the first question is solved over here. ठीक है? So this reaction is feasible in liquid ammonia. Why and how? Because whenever any alkali is dissolved in liquid ammonia, it results in the formation of ammoniated electron. This electron actually acts as a very good reducing agent, so it can actually reduce FeCO5 to this. So this is a feasible reaction which we have already discussed. Now let us move on to this reaction, whether this KNO3 plus AgCl ये reaction feasible है कि नहीं. तो ये करने के लिए बहुत डिटेल में हमें बहुत सारी चीज स्टडी करना है, and that is the metathesis reaction. So basically metathesis reaction, if I explain you in a single word, so metathesis reaction is nothing but exchange of partners. You can say that metathesis reaction is exchange of partners. For example, when AX reacts with BY, it results in the formation of AB and XY. So it is clearly visible to you that A and B, they are getting exchanged, and X and Y, they result in the formation of the bond. कोई भी simple reaction, if we say that whenever acid reacts with base, when acids reacts with base, this is also an example of metathesis reaction. See, it results in salt and water. तो ये metathesis ही हुआ ना, यहाँ पे exchange of partners ही हुआ. So this is also an example of metathesis reaction. Now, if you talk about the dielectric constant, now I need to define you what do you mean by the dielectric constant. So this is very important. See students, we know whenever you dissolve a very soluble substance like salt in water, what happens? So whenever salt NaCl gets dissolved in water, first salt NaCl, it gets dissociated to its corresponding ions. ये डिसोसिएशन कौन करता है? ये डिसोसिएशन सॉल्वेंट करते हैं. सो ये जो आयनिक बॉन्ड है, द स्ट्रॉन्ग आयनिक बॉन्ड बिटवीन द कैटायन Na plus and the anion Cl minus, that bond is first dissociated by the solvation energy of the water. जिसका बॉन्ड डिसोसिएशन करने का कैपेसिटी जितना ज्यादा होता है, that is defined by the term dielectric constant. That is defined by the term dielectric constant. Now, usually it is said that the dielectric constant of water is considered to be highest as a solvent, and it is equal to 1. It means the capacity, the capability of the water as a solvent to break the ionic bond between the Na plus and Cl minus is highest when the water is acting as a solvent. But the dielectric constant of liquid ammonia is very less. That is why liquid ammonia is not capable. KCl हो गया अगर आप NaCl भी लेते हो, NaCl हो गया अगर आप KCl भी लेते हो, फॉर एग्जाम्पल KCl जो है, KCl will get dissociated into K plus and Cl minus. ठीक है, sorry I have written OH minus. K plus and Cl minus. Now कैसे dissociated होगा? The solvent must have that capacity to break the ionic bond between K plus and Cl minus. Both of them can be dissociated by water and they get dissolved in water. So they are soluble, both of them, NaCl and KCl, they are soluble in water because the dielectric constant of water is very high. The power to break the ionic bond between the cation NaCl Na and the anion Cl minus is strong. But since the dielectric constant of liquid ammonia is very less, that is why both of them are insoluble in liquid ammonia. This is very important question. Clear? So see, I have beautifully described it in the form of note. See, the lower dielectric constant of ammonia results in a decreased ability to dissolve the ionic compounds. ठीक है, तो that is why since liquid ammonia का dielectric constant कम है, तो ये it results in the decreased ability to dissolve the ionic compounds. क्योंकि ionic compound dissolve होने के लिए first of all इसे dissociate होना पड़ेगा. Dissociated होने के लिए solvent का dielectric constant high होना चाहिए, जो कि water का है, liquid ammonia का नहीं है. Now इसका जो consequences है वो बहुत ही ज़्यादा interesting है. Before I proceed, एक important information देना है. AgCl जो है this actually forms a soluble and stable complex with liquid ammonia. ठीक है, AgCl जो है it forms a stable complex with liquid. So it is silver halides. They are insoluble in water, but they are soluble in liquid ammonia because it results in the formation of a stable complex with ammonia. तो एक information हमें मिल गया है that AgCl जो है it is insoluble in water but it is soluble in liquid ammonia because it results in the formation of a stable complex with ammonia. Now अभी जो एक रिएक्शन हम करने वाले हैं, दिस इज सो वेरी इंटरेस्टिंग बिकॉज अब देखो ये रिएक्शन तो सेम है but the direction of the reaction is determined by the nature of the solvent used. But the direction of the reaction is now determined by the nature of the solvent used. So this is the forward reaction which is resulting in the formation of BaCl2 and AgNO3. And the backward reaction will result in the formation of this part, the left LHS part. Now important part है कि एक तो हमने already discuss कर लिया है that AgCl जो है वो water में insoluble है, so AgCl will form a precipitate in water but not in liquid ammonia. Clear? Now see students, BaCl2 ये जो है this is soluble in water. Q. Because again the same story, because of the high dielectric constant of water, it can actually, the water can actually result in the dissociation of barium chloride. So it can actually break the strong ionic bond between the cation and the anion. But this is insoluble in liquid ammonia. As a result of which, in liquid ammonia, barium chloride will form precipitate, but barium chloride is soluble in water. So the same reaction जो हमने अभी लिखा है, इसका जो forward reaction है, so if for this इसका जो forward reaction है, it will take place in liquid ammonia. This will take place in liquid ammonia. और इसका जो backward reaction है, the backward reaction, the direction, this will take place in water. Q. Because in liquid ammonia, BaCl2 will result in the formation of the precipitate because liquid ammonia, due to its extremely lower dielectric constant, it cannot break the ionic bond, strong ionic bond between the cationic part and the anion and Ba2 plus and Cl minus. But since AgCl is soluble in ammonia due to the formation of a stable complex, so and AgCl is insoluble in water, so इसका जो backward reaction है in which AgCl is resulting in the formation of precipitate in water, it will take place, or BaCl2 will result in the precipitate in liquid ammonia. The same story is again with KCl. As just I discussed that KCl जो है, KCl भी insoluble in liquid ammonia होगा because of the lower dielectric constant. So insoluble in liquid ammonia because of the lower dielectric constant of liquid ammonia, but water is enough capable to break the bond of K plus and Cl minus. So water में ये soluble होगा, तो liquid ammonia में KCl का precipitate होगा. So it will result in this direction, ठीक है, and in water it will result in the precipitate of AgCl. Now one more important thing you might ask that madam दोनों ही reaction हो सकता है, but I must tell you one important information that this you see is unidirectional reaction. Why is it so? Because देखो दिस इज वेरी इंपॉर्टेंट, कभी भी A प्लस B अगर वो रिएक्ट करके फॉर्मेशन करते हैं C प्लस D में, ठीक है, सो हाउ इज दिस रिएक्शन टेकिंग प्लेस? फर्स्ट ऑफ ऑल द रिएक्टेंट विल रिएक्ट अमंग देमसेल्व्स रिजल्टिंग इन द फॉर्मेशन ऑफ द प्रोडक्ट, एंड आफ्टर सम टाइम व्हेन C एंड D काफी अच्छे अमाउंट में प्रोडक्शन हो रहा है, देन द प्रोडक्ट विल आल्सो react among themselves and will get reverted back to the reactant. What will happen if you actually separate, or if you remove any of the product, for example, if C is removed in the form of any precipitate or in the form of any chelating complex, or suppose if C is a gas and it is evolved out of the reaction mixture, being a gas and it is evolved out of the reaction mixture, somehow if C is removed, तो ये backward reaction नहीं होगा, then this unidirectional, then it will turn out to be unidirectional reaction. समझ में आ गया? So यहाँ पे आप लोगों को unidirectional reaction हो रहा है because in this reaction in water, जब वो water है तब आपको precipitate आ रहा है किसका? AgCl का. Now AgCl precipitate, as because AgCl is getting precipitated, that is why the backward reaction is not possible. So you have तो unidirectional reaction होगा, ये reaction complete हो जाएगा, ठीक है? Because now this AgCl is getting precipitated, so it can no longer react with KNO3 to get reverted back to the formation of reactant, नहीं हो सकता है. So this is very very important concept. So वही reaction तो same है, लेकिन इसका जो forward direction वो होगा, इसका जो forward direction वो water में होगा, this is very important, ठीक है? But इसका जो backward direction है वो होगा liquid ammonia में. So this will take place क्योंकि लिक्विड अमोनिया में KCl को लिक्विड अमोनिया डिसोसिएट नहीं कर सकते, इसलिए KCl का प्रेसिपिटेट करते हैं, तो ये यूनिडायरेक्शनल बन जाते हैं और ये एक्शन कंप्लीट भी हो जाएंगे और बैकवर्ड रिएक्शन इसमें पॉसिबल नहीं है. एंड सिंस AgCl इज इनसॉल्युबल इन वाटर, सो यहाँ पे AgCl का प्रेसिपिटेट होगा एंड दैट इज व्हाई यहाँ पे भी बैकवर्ड रिएक्शन नहीं जाएंगे और ये यूनिडायरेक्शन रिएक्शन होकर ये कंप्लीट रिएक्शन हो जाएंगे. सो इन लिक्विड अमोनिया दिस direction is feasible reaction. So in liquid ammonia this direction is feasible reaction, जहाँ पे KCl precipitate देते हैं. So now let us move back to the question. So whether this reaction is feasible or not. So देखो, so you see KNO3 in AgCl is a feasible reaction because in liquid ammonia KCl results in the formation of a precipitate. So in liquid ammonia we get a precipitate of KCl. So this is a feasible reaction in liquid ammonia. इसका opposite reaction कहाँ पे feasible होता है? Water पे, जहाँ पे AgCl precipitate देते हैं. Clear? Now the next part, this is a very important reaction. So I have also explained this reaction as neutralization reaction. So neutralization reaction अगर मैं आपको बताती हूँ तो आप तुरंत एक एग्जाम्पल दे देंगे, मैडम इन वाटर में अगर हम बात करते हैं तो हम बोलेंगे when acid reacts with base or alkali it results in the formation of salt and water. And we name it as a neutralization reaction. So neutralization reactions, you can say, I have already written. So neutralization reaction जो already आप बोल सकते हो वो ये है that it actually can be run that goes parallel to this. एकदम simple language में आपको बता देती हूँ, जहाँ पे प्रोडक्ट में आपको सॉल्वेंट मिल जाता है, यहाँ पे सॉल्ट तो मिलते ही है, ठीक है, प्रोडक्ट में यू एक्चुअली गेट योर सॉल्वेंट बैक. व्हाई इज इट सो? देखो न्यूट्रलाइजेशन मतलब जहाँ पे कैटायन भी नहीं है एनायन भी नहीं है, ठीक है. सो वाटर जो है वो पहले डिसोसिएट करते हैं टू इट्स कैटायनिक पार्ट एंड एनायनिक पार्ट. सो रिएक्शन जब न्यूट्रलाइजेशन रिएक्शन होता है तब आपको अगर प्रोडक्ट में वाटर या सॉल्वेंट मिलते हैं, वाटर विच इज एक्टिंग एज अ सॉल्वेंट, मतलब यहाँ पे आपका कैटायनिक पार्ट और एनायनिक पार्ट और present नहीं है, it's a neutral one, so you can actually explain it as neutralization reaction. So I have given you two examples of this in the case of the ammonia, liquid ammonia, जहाँ पे आपको प्रोडक्ट में you are getting the liquid ammonia solvent. So this is an example of neutralization reaction. So again, let us move back to this question. Yes, this reaction is also feasible, and this is an example of neutralization reaction. Very important. This is very important. एकदम सिंपल वर्ड में आप क्या बोल सकते हो? Yes, it is resulting in the formation of a salt, and also you get the neutral solvent, which is the liquid ammonia, NH3. So the answer is all the three reactions are feasible. Answer is 1, 2 and 3. ठीक है? Now I'm going to explain you the next question. This is also very important from the topic liquid ammonia. So यहाँ पे कैसे different जो column A है, you have to match it with column B. कैसे different substances react करते हैं liquid ammonia, वही हम explain करेंगे. तो ये चीज़ explain करने के लिए मुझे बहुत अच्छे से आप लोगों को leveling effect of ammonia को demonstrate करना है. So liquid ammonia acts as a leveling solvent. So what do you mean by the leveling solvent? बहुत easy way में मैं आपको बताती हूँ. देखो, अगर कोई एग्जाम अगर होता है, ठीक है, वो एग्जाम जब बहुत इजी हो जाता है, देन इट एक्ट्स एज अ लेवलिंग सॉल्वेंट. सारे स्टूडेंट्स उसमें बहुत अच्छे से कर लेते हैं, सबको अच्छे मार्क्स मिलते हैं. बट वही एग्जाम जब काफी डिफिकल्ट हो जाते हैं, वहां पे ओनली द स्टूडेंट्स हु आर वेरी गुड इन प्रिपरेशन, वही स्टूडेंट्स उसे क्वालिफाई कर पाएंगे. ठीक है. सो जब एग्जाम इजी था, इट वाज एक्टिंग एज अ लेवलिंग सॉल्वेंट. जब एग्जाम डिफिकल्ट हो गया, इट वाज एक्टिंग एज अ डिफरेंशिएटिंग सॉल्वेंट. सो आपको मैं बता देती हूँ उसे और अच्छे से एक्सप्लेन करने के. फॉर एग्जाम्पल वाटर जो है, सो वाटर इज एक्टिंग एज अ डिफरेंशिएटिंग सॉल्वेंट फॉर दिस एसिड्स, जहां पे HClO4 जो है is maximum acidic in nature, is strongest acid, and it is stronger than HNO3, and acetic acid is a weak acid. अच्छा, अगर मैं आप लोगों को कहती हूँ that acetic acid is a weak acid, तो ये ना एक incomplete sentence है, and ये wrong भी हो सकता है, can be considered as a wrong statement. Why? Because acetic acid is a weak acid in water. So whenever you are going to explain about the nature of acidity or basicity, you must mention the solvent used. ठीक है. So water is acting as a differentiating solvent because in this case HClO4 is the strongest acid and is stronger than HNO3, and this is the strongest acid, and this is a weak acid in water. But this is not so in the case of liquid ammonia. Since liquid ammonia has got a strong tendency to accept proton, so almost everyone, they actually act as a strong acid in liquid ammonia. Obviously यहाँ पे जो examples मैंने दिया है HClO4, they are very strong acids, तो वो तो लिक्विड अमोनिया में बहुत अच्छे से एज अ स्ट्रॉन्ग एसिड बिहेव करेंगे ही, बिकॉज ये तो करेंगे ही, बिकॉज ClO4 माइनस ड्यू टू इज हाई रेजोनेटिंग स्ट्रक्चर, इज अ वेरी strong resonating structure, so that is why it gets dissociated into H plus and ClO4 minus. तो ये तो strong acids है ही, इसमें कोई डाउट नहीं है. But जो कि acetic acid was considered to be a weak acid in water, since the proton accepting capacity of, देखो लिक्विड अमोनिया जो है ये बहुत ही एक्सेप्ट्स प्रोटॉन रेडिली, सो इट एनहांसेस द आयनाइजेशन ऑफ द सो कॉल्ड वीक एसिड सच एज एसिटिक एसिड इन वाटर. दिस इज वेरी इंपॉर्टेंट लाइन. सो एसिटिक एसिड वाज कंसिडर्ड टू बी वीक इन वाटर, सो डोंट से द एसिटिक एसिड इज अ वीक एसिड, इट्स अ इनकरेक्ट स्टेटमेंट. सो एसिटिक एसिड इज अ वीक एसिड इन water when water is used as a solvent. ठीक है. But since the proton accepting capacity of ammonia is very high, ये acetic acid से भी बहुत easily सारे protons accept कर सकते हैं, as a result of which acetic acid completely dissociated हो जाएंगे, and this acetic acid in liquid ammonia will now act as a very strong acid. Acid in liquid ammonia. So I hope this is clear to you. This is very interesting and very important. ठीक है? So acetic acid जो है, it is acting as a strong acid in liquid ammonia because liquid ammonia accepts proton readily and it enhances the ionization of acetic acid, and now this acetic acid in liquid ammonia will get completely dissociated and will now act as a strong acid. ठीक है? So this we have already solved. ठीक है? Now the answer for acetic acid is a strong acid. So we already solved this. So C will result to 2. So let me write C will result to strong acid. Acetic acid being a strong acid in liquid ammonia. Okay, now let us move on to the next one. So that is why again liquid ammonia ये मैंने बहुत अच्छे से नोट फॉर्म में दिया है, आप इसे भी रेफर करो, आपको बहुत फायदा होगा. Because in our class we provide the best quality study material and I worked 9 years in making this study material. उसी का कुछ पार्ट में YouTube में भी आप लोगों को हेल्प कर रही हूँ. ठीक है? Now इसके ऊपर ऐसा है that ऐसा कुछ है जो मॉलिक्यूल्स, फॉर एग्जाम्पल यूरिया, जो मॉलिक्यूल बिल्कुल भी एसिडिक बिहेवियर नहीं दिखाते हैं, जो मॉलिक्यूल बिल्कुल भी एसिडिक बिहेवियर नहीं दिखाते हैं, वो मॉलिक्यूल भी एक्ट करते हैं एज वीक एसिड इन अमोनिया. सो दिस इज अ वेरी गुड एग्जाम्पल ऑफ यूरिया. इफ यू टेक यूरिया एज एन एग्जाम्पल, ठीक है, so in this case you have urea. Now this urea, which is a complete neutral, it acts as neutral in water, ठीक है. Since ammonia has got a strong capacity to accept proton, so that is why this will again act as a weak acid in liquid ammonia. The same story. So urea जो हो जाएंगे, urea is acting as a weak acid in liquid ammonia. So we have D to be 1. Clear? So the similar way ammonia का proton accepting capacity इतना ज़्यादा है जो कि acetic acid जो which was acting as a weak acid in water, that उसका भी complete dissociation हो जाता है क्योंकि अमोनिया उससे प्रोटॉन रेडिली एक्सेप्ट कर लेते हैं. इवन दो द यूरिया जो completely न्यूट्रल था, बिल्कुल भी H+ को फर्निश नहीं कर रहे थे, बट since the ammonia which is having extremely, this is the nature of the solvent, is having extremely strong capacity to accept proton from urea. ठीक है? So that is why this urea is acting as a weak acid in liquid ammonia. Clear? Then you have Cl2 and S8. इसे भी हम पढ़ाई कर लेते हैं. Now let us understand. So Cl2 जो है, I have written the reaction. It is solvolysis and disproportionation reaction. Obviously disproportionation reaction तो सबको पता है, it is a redox reaction जहाँ पे it gets oxidized and reduced at the same time. ठीक है? Now Cl2, it is getting oxidized in the form of HOCl and reduced at the same time. So this is an example of disproportionation reaction. No doubt about it. This is very easy. So what do you mean by the solvolysis? Now exactly opposite to neutralization reaction is solvolysis. Neutralization reaction मैंने आप लोगों को क्या explain किए थे, जब आपको प्रोडक्ट फॉर्म में आपको सॉल्ट एंड वाटर मिलता है, मोस्टली द वाटर और द सॉल्वेंट, जहाँ पे आपको आयनिक फॉर्म में नहीं हो रहा है. तो कोई भी सॉल्वोलिसिस में जो आपका, फॉर एग्जांपल आपका जो अमोनिया है, मैंने ऑलरेडी आपको एक्सप्लेन किए थे, इट गेट्स डिसोसिएटेड इनटू द कैटायनिक पार्ट NH4+ एंड द एनायनिक पार्ट NH2-. अगर आपको राइट हैंड साइड प्रोडक्ट फॉर्मेशन में अगर आपको कैटायनिक पार्ट एंड एनायनिक पार्ट दोनों ही मिलते हैं, ठीक है, इन दिस केस यू सी डिस्प्रोपोर्शंस तो हमें समझ में आ ही गया है, बिकॉज इन दिस केस क्लोरीन जो है इसका ऑक्सीडेशन स्टेट है आपका +1 बिकॉज NH2 माइनस है, ठीक है, एंड ये जो है इसका ऑक्सीडेशन स्टेट है -1 Cl minus. So you see in the product form you are actually getting both the anionic part and the cationic part of the solvent. तो इस type of reaction जो है इसे हम बोलते हैं solvolysis, जहाँ पे it is exactly opposite. न्यूट्रलाइजेशन रिएक्शन में आपको solvent मिलता है, ठीक है, बट आप जब solvolysis हो जाएंगे आपको उसका cationic part and the anionic part in the product form आपको मिलेंगे. So this is an example of solvolysis and disproportionation. Clear? Now the next part is disproportionation. So this is very easy. तो ये तो this is clear that it is getting oxidized, it is getting reduced. तो यहाँ पे आपका reduction हो गया and it is getting oxidized. यहाँ पे हो गया आपका oxidation. So लेकिन in this part you cannot see, यहाँ पे आप बोले मेरे NH4 plus है, NH4 plus है, NH2 minus नहीं है. So this is example of only disproportionation, not solvolysis. But chlorine Cl2 in liquid ammonia is an example of solvolysis plus disproportionation. So this is very important video. ये आपको बहुत ज़्यादा आपका concept clear होगा और इसकी वजह से आप बहुत सारे questions, incoming questions भी कर सकते हो. That is chlorine जो है, A जो है, chlorine is an example of solvolysis and disproportionation. A is an example of solvolysis and disproportionation, and S8 is an example of only disproportionation. So B is going to be 3. So the answer is A4, B3, D1 and C2. So this is the answer. Very important. Just go through this video 2 to 3 more than one time, so it will give you a lot of important information about liquid ammonia. मैंने बहुत सारा characteristics of liquid ammonia को इस वीडियो में ब्यूटीफुल एक्सप्लेन तो किया ही है और मैंने इसे नोट फॉर्म में दिया है ताकि स्टूडेंट्स को कुछ ऐसे पढ़ने के लिए मिले, क्योंकि once you get a beautiful study material then only your preparation becomes complete. Without a best study material your preparation can never ever be complete, because I worked 9 years to make this study material. ठीक है, obviously वो तो अच्छा होगा ही. Someone is working years and years to make the best quality study material for you, and what kind of study materials you are making, I have given you some examples over here. It will help you as well. So this is the end of the video. Thank you for watching our video. If you like our video, do press the like button. Thank you.